Hello, everybody, and welcome. It's good to see a lot of people here already. I want to welcome you, and let's just wait some minutes to start this webinar. Um, I can see that there is a lot of people from Latin America, so I want to welcome them em Spanish, em português. Olá a toda a gente, bem-vindos a este webinar da O-Pitblast, o nosso primeiro webinar. Vamos fazer aqui alguns minutos em que podíamos identificar qual é o nosso país, a vossa empresa, profissão. Saludos a la gente de Latinoamérica, hispanohablantes. Mucho gusto de vos presentar este webinar. Si queráis pueden comentar en nuestro chat sus dudas y pueden comentar su país y su compañía. Hello for everybody that is coming now. We will be presenting this webinar in 3 minutes, but meanwhile, it's good that we can identify ourselves, our countries, and our companies. I can see people from Chile here, Bolivia, people from Mozambique. A warm hug to Moatiz, Mozambique. A lot of my ex-colleagues are there. Also Greece. I want to greet people from Greece, Peru, Brazil, and Ecuador. It's so nice to have a lot of people from different countries here. We'll be presenting a training. I hope that you like. In 2 minutes, we will start this webinar, okay? So if you can tell us where are you watching this webinar from and what is your company, it's good for everybody to get to know each other in this chat on YouTube. Let's wait just more 1 minute. We have a lot of people watching from Latin America, but this webinar will be presented in English. I hope my English can be clear for you to understand. But you are welcome to write in the chat your questions in your language, Spanish, Portuguese, and you can also send us an email with further questions that you might have, okay? So in 1 minute, we will start the webinar, okay? I'm here inviting in the chat for everybody. Say what is your country. And let's start. It's time. Let's start with the webinar. I want to welcome everybody that is here on this webinar of O-Pitblast, our first webinar. I want to present myself. I'm Pedro Pereira, and I'm a mining engineer. I want also to thank you to all the companies that made this possible. Okay, so I want to thank Forseat, NIX, Hanwha, Whipware, Capex, Hydrodet, and Cadex, our partners that helped us to make this webinar possible. If you follow us on our social media, you know that we, in these past weeks, we've been providing some trial license for you to try our software, and now we'll be providing online training in this webinar of approximately 1 hour, so you can understand a walkthrough of a blast design. Okay, we'll be also providing some gifts. We'll be doing a raffle of 2 gifts. It will be O-Pitblast backpack kit and also a ticket for the interconnected mining experience, the first online conference of mining engineer from Brazil. This is being present by Mining Innovations. Okay, so let me excuse some moments to speak in Portuguese and Spanish. Queria agradecer a presença de toda a gente neste webinar, a todo o público de língua portuguesa, principalmente um abraço para o Brasil. Estava agora a referenciar que nós vamos oferecer um bilhete para o Interconnected Mining Experience, um evento em que vamos participar com 2 engenheiros, a Raquel Sobral de Portugal e o Tales Xavier do Brasil. Então pode ser que consigam a sorte de ter um ingresso para este evento. A todo o público de Latinoamérica, hispanohablantes, vos quería saludar. Es con mucho gusto que os ofrecemos este webinar, y todas las dudas que pueden tener, vos invito a comentar y nosotros las vamos a contestar, o nos pueden escribir un correo. I was saying that I want everybody to feel comfortable and feel free to write down the questions in the chat, or you can give us your email, or also email to info@opitblast.com, and I will be just presenting here that we have a lot of global presence in the world, here in Peru especially. Okay, and I want to present another way that O-Pitblast is making business. We will be presenting something new, and I hope that you like this. Okay.
O-Pitblast is looking for finders. Do you have contacts in the blasting industry? Wherever you are, if you have a business opportunity, talk to our consultants. Sign up and order our media kit. O-Pitblast, check out our social networks. Send an email to info@opitblast.com. Contact us and you'll be entitled to a commission. We can grow together, so let's do business all around the world. O-Pitblast, with us, it's possible.
Okay, is everything okay? Yes. So I was saying that the course is structured by a box cut blast design, a final pit design, and also a free face blast design. Okay, so I'll be going now to present this webinar. I hope that you like, and if you have questions, you can forward it to our email. Okay, so thank you very much, and please enjoy. Okay, so let's start by opening the software O-Pitblast. This is a splash screen, and as I told you, we will start by presenting the type of blast called box cut, and this is a blast in which we don't have a free face, we just have the surface above. This is the first view of the software. We have here a presentation of the step-by-step tutorial for people who are not familiar with the software. This is the overview, but let's start by importing some terrain. This is the pit update. So now the software asks us, well, we have to tell which is X, Y, and Z information on the file. so the software can produce the triangulation. Okay, so it will ask us for outliers. We recommend to eliminate those outliers. Okay, so this is the terrain. This is finishing the triangulation. Okay, good. So this terrain was built in the fields by a GPS survey controller, GPS controller. So we don't have a lot of detail like it was from drone. Okay, but I will show other examples. So let's start by importing polygon from the planning team. Okay, they will send you a polygon, and here you have to use a separator. So in this case, it's a comma, and again, tell the software what is X and Y, and import. And yes, now we have here our polygon. We can change color to have a better look. Okay, so we will blast this as a box cut because we don't have free face. So another thing that I want to show is how to import layers, and I will import the layer of the pitch shell. Okay, so just like importing a terrain, you have to tell what's X, Y, and Z because we are working with CSV files. So this is the pitch shell. So we have here the pitch shell. So this is the final pitch. Okay, and now I will also import the floor and the roof of the seam. So again, same method, separator X, Y, and Z. And this is the floor. And again, the roof, I will import. And call it the roof. Cool. So I will now change some colors for you to understand what we have here. A lot of information. So this is the bench bottom, okay, this line. And for example, let's change the pitch shell can be red. We can change upper and bottom color. The floor can be yellow, for example. And the roof can be green. Okay. Cool. So we can see we have first is pitch shell, then we have here we have the floor, the yellow, and in green we have the roof. Okay, I will start by throwing here some holes. We have this big function is head hole. By right click on the polygon, I will set up my burden and my spacing, and I will set up as a staggered pattern. I can adjust here. Okay, if I'm happy with it, I'll press OK. Cool. These boreholes are going all the way to the bench bottom. Okay. You can see they have a subdrill. They are going to the bench bottom. I will change my bench bottom for you to have a better look for level 150. So now it's below. Let's edit all the holes. The bench bottom. Okay, they are on the bench bottom. They have 1 meter subdrill. Okay, I can take this out. No subdrill. Okay, they are on the bench bottom. What I will do now, I will throw all the holes to the pitch shell. Okay, I don't want to drill below the pitch shell. So I'll adjust and apply. Okay. Sorry, all the holes for the pitch shell. Yeah, cool. They are right on the pitch shell. Okay, so we have a lot of information here. I will set up this. For example, maybe we don't need to see the pitch shell now, and we don't need to see the bench bottom neither. We are not working with the bench bottom, and we can clearly see that we have a floor in yellow and a roof in green. Okay, so what I want to show a cool feature that we have is to apply charge and apply an automatic decking on between layers. Okay, so that's what I'm going for now. So we can click in a hole. Let's open this window, borehole information. I'll put it bigger like this. And let's see. I can also set up here first and change the aspect of the of these layers, because I will put this as a solid triangulation. So the floor will be solid and also the roof will be solid. I think we can see better like this. So entering one hole, the borehole information. Let's see this hole. Okay, we can clearly see this is the pit shell, and we can clearly see below the seam and above seam. Okay, so let's put some charge. Quickly set up two elements. Can be a booster, put a booster one, and emulsion. This is bulk explosive chemit. Force it. I'll put 100% of the charge column. Okay, but I don't want this. I want a deck, so I can apply. I want to set a deck between the floor layer until the roof layer. Okay, and I will apply. And now I have here my deck. I don't have explosive. It puts another booster for the next charge, and we can see clearly that it's cutting on the layers. What we can do also is, for example, we can change the offset, and I will show, for example, I'll do this again for you to understand. 100%, and then set up a deck. But now we want from the floor to the roof, but we want an offset, for example, alpha meter, and we apply. Okay, let's see. We have here alpha meter. We have one. No, the seam is 2 meters, and then alpha meter again. Okay, so I can also apply for all the holes, and we can see in different holes. Okay, you can see clearly. Okay, so all the holes are charged exactly the same way. Okay, when they have this red circle, it means they are charged, and we can also see the charge. Okay, let's see. Charge instead of length. Okay, so they have different charges because they have different quantity of explosive, because also they have different lengths. I guess this makes sense to you. So I want to show another cool feature that we developed, is that we can edit holes by geometry. Okay, and for example, I don't want to drill less than 10 meters, so I will filter all the holes that have a length below 10 meters. Okay, and now I will go to bore holes, I will edit those holes, and I will say my length will be at least 10 meters. Okay, not 100, 10. And apply, and every hole have more length than 10 meters. Okay, so they are all charged, and this is a box cut that I want to show you. And let's go, for example, to print to see the average charge rule. Okay, charge rule design. So this would be our charge rule. Okay. Okay. So now going for another type of blast, I want to show a final pit design. Okay. So we'll start by importing another terrain. It will be a final pit design. So this file is a little bit different. It's a DXF. So we have here this window. We select what data we want to enter. I select all data, and now we have the same procedure, selecting X, Y, and Z. Okay. So let's import this terrain. This is a segment of bits. Will ask us again if we want to eliminate outliers. Okay, go for that. And here it's the terrain. We have here some final bit, final slopes, and we want to do the next one. Okay, so I will start by importing a line. This is the line of the crest and the toe of the slope 1536 of relative level. Okay, I will import this LW polyline. I will select X, Y, and Z. Okay, cool. And we have it here. So we can see the crest and the toe of the next slope. Okay. Another thing that we can do from the same file, we can import this as a layer. So let's do it. You will understand what's the idea. Get a better view of the slope. Okay. Yes, so this is a layer. Okay. And again, our team of planning sent us a polygon. Let's import that polygon. Here, import polygon, separated by commas, X, Y, and Z. Actually, we don't need Z for polygon. This will apply on the terrain. You can change the color. Let's work with yellow. Okay, let's see in 2D view. Okay, we have here the polygon, and we have the crest and the toe. Okay, for this type of blast that we want to respect the position of the boreholes on the crest, maybe we could do a pre-split and buffer holes. We have a cool feature for this is creation of pattern from back, and I will explain how this tool works. So it's based on a line, and we have to select that line. So let's start by selecting the crest line. Okay, so we have here selected, and now we will create more rows. Let's create some more rows. We will choose reverse to put the blast for this side, and we can choose staggered. And now a cool feature is that we can choose multiple burden and multiple spacing. So my average will be 6 per 7, 6 burden, 7 spacing. I will put here also. Okay, so between the crest and the toe, I have 6 meters of distance. I will put the row of the burden of the buffer, to be on 7, for example. No, actually, let's put it 8. Okay, I'm sorry, I misclicked here. Reverse. Okay. So, and the spacing, let's put it by 7. Okay. I will start by adding these parameters, and I will change individually. So the first 8, then let's put, for example, 5, because it's a buffer, a little bit less burden. And okay, put more rows. And in this row, I will choose a different spacing because I want it to be a press plate. So half of the spacing, and now it's a free split. Okay. And let's see. Yeah, for me it's cool. One thing that I can do right now is that I can edit the label, and I will choose automatically. And for example, last last row I'll call it press split, and maybe call a buffer on the other, and press OK to see the label. And when you feel that everything is okay, you press apply. So let's see. Okay, everything is applied. We have a lot of information here. Charge, we don't need to see charge for now. And length, we don't need that neither. Okay, so you can see press split, buffer. Okay. So you might ask, why don't I have boreholes here? I want to show you that we can adjust by adding a row near a other. Okay. So it's asking me after what row. I will choose after row number 1. And if you don't know what is a row, we can show here rows. So row number 1, let's put and add one row of boreholes with the spacing of the 7. Keep the same spacing, and the burden will be 6, but we want -6 because we want for this direction. Okay, and we want to choose also staggered. Okay, one staggered. Okay, we are happy with this, and one more line. So the next thing I would do here, let me just take this out, would be selecting all the holes that are out of the polygon of the blast. Okay, and I will delete by just click on delete button. Delete all the holes inside the polygon. Yes, please. So everything is set. And for example, now I can show you some adjustments. For example, this hole is outside. I will move this hole, and I will show you actually some other features that we have is proximity ring, and we can select the radius that we want to see and that are critical to us. And for example, 4 and 6 meters. So in this moment, I know that this hole is being away 6 meters. Okay, so I will adjust like this, and I can adjust here also these holes. So I'm showing you these tools you apply on your blasting project. I can add more holes in the places I feel that I need to add. Let's see if they are correct positioned. Yeah, cool. So with this tool, you can see distance between all the holes on the surrounding area. Cool. Yeah, so that's the idea of the adjustments that you can make. So what I want to do now, I can quickly delete the polygon. I want to do now is to select, first I have to correct this. So I will show the importance of line editor. So the line editor is for us to, we want to tell the software what boreholes belong to each line. So this is very important for renaming and editing label automatically. Okay, so by doing this, I'm telling the software what hole is in each row. Okay, we have to draw, but you will see that this is very important. Okay. Almost. Okay, and now you press split. Cool. So now I can easily adjust this automatically. So the same idea, buffer and press split and apply. Okay, so I got A, B, C, D, and therefore. So let's do cool thing that I want to show you is to select now the contour holes, and we will edit this type of hole. So I will say that these are the contour holes, and now the same thing on the buffer holes. Cool. And I will say these are the buffer. The other ones are production. Okay. I can select all the other holes as production. Okay. Now I can change individually some parameters, or I can keep changing from all blast holes. For example, let's put a diameter of 311 millimeters. So this will be my diameter. And let's change some things. For example, okay, stemming. Okay, and adjust this all to bench bottom. Let me just verify the bench bottom. Let's put on the same level. I will do this again. Just bench bottom. Okay. So now that I have everything defined, it's easy to change the parameters. So for example, I'll just change the buffer boreholes, and I will change diameter. Instead of 311, I'll put 270 millimeters. And I will change the stemming for 7 meters, for example. And I will put here a sub-drill of half a meter. Okay. Cool. Apply. Different stemmings. I will quickly change the production holes to have a sub-drill of 1 meter. Okay, other parameters are fine. And now I will change contour, and the contour I want them to have like 9 meter stemming and not sub-drill. I will not put, but I will change diameter for blast because it's a pre-split. I will apply. Okay, so now I have different diameters. Okay, you can see. But now, because I want to respect the slope, this is important, is to define the inclination and the azimuth that we want. So I will set up this azimuth. So I want these boreholes to have inclination in this direction, this on this direction, this last one on this direction. So let's start by selecting just these boreholes and edit. Okay, so these boreholes, they will have an inclination. I'll put, let me see, for example, 20 degrees, and the azimuth will be here, this azimuth, 219. Let's see what happens. Apply. Okay, they already have some inclination. I'll do this for the next trench of contour. Edit, inclination. Let me put the same, and azimuth. Let's see, 223. Okay. Let's see if this works. And the last or boreholes of contour. Let's see, edit, the same inclination, but a different azimuth. 2, 3, 2. Okay. Let's see how it goes. If I need to do some adjustments. Yeah, let me see. These boreholes are a little bit closer. I can see the burden or spacing in the toe. Yeah. So my recommendation would be to change a little bit here the azimuth. Let's see if this works. Yeah, a little bit. And also here, you can take a little bit the azimuth. Okay, makes this more even. Yeah, I'm happy with this. Let's see the result of the design. Let me take this out. A lot of information. Okay. So now I have a pre-split complying with the slope with different stemming. Then I got the buffer with different, with just half a meter of sub-drill, and then I got the production boreholes. So this is my suggestion of designing the final pit design. Okay, and you shouldn't mind with the length of the boreholes depending on your type of operation and your type of drill rigs. But let me just see the length, because the length is provided by the topography that we have in this moment. But actually, what you have to export for the drill rigs should be a CSV, or depending what type of file that you want. But if you are doing a CSV, I would just recommend to export the label, and then the toe position would be, and the color position. So you don't need the Z of the color. You will need the Z of the bench bottom that you want to do. So this is my suggestion for this type of blast. Okay. And finally, I will import another type of terrain. I want to show you a different type of blast. It will be a free face blast. Okay. So again, same procedure. For this blast, I will import terrain built from drone topography. Okay, this has more information, so it is taking more time. But for the free face blast, we would recommend to use drone technology, in which you can keep more data, more quantity of point cloud for to have a better idea of the free face. Okay, because if we have more information on the free face, we can adjust the first borehole to have a better critical distance of the burden on the free face, and that's what I'm aiming for. Okay, finishing the triangulation of the terrain, as I told, was built from drone survey, so we can see the amount of detail we have here on the free face. So I can show the points, or let's see, as a wire triangulation, you can see a lot of detail. It's better for this type of design, free face blast. Okay, so one thing that is very important is that we have to build our database with our products as detonators, boosters, bulk explosive. Okay, set up our diameters, everything. This is very important. Okay, so and putting price tags on every product. In the moment we have that, we can start our design. So the first thing here would be set up the crest and the toe. And let's go here and design the crest. To help with this, we can set up a contour level. Okay, contour line. So now I can go here, start designing. Okay, I will design my crest, but obviously I'm not very rigorous. I'm not very accurate. So and also the toe. So the best thing here is to ask for our survey team to go and survey the crest and the toe, and we can import the file directly. So I will import the crest. Okay, I will have to set up X of the crest, Y, and Z. So, but now I have my crest, and I will do the same to import the toe as a DXF file. Okay, X, Y, and Z. and it's done. Okay, so another thing that I have to do is I have to ask the planning team for the polygon, and let's import this polygon they want us to blast. So again, same thing, X and Y. Let me change the color for us to see better. Okay, so now I have my polygon here. I can start with the design. I will recommend the create pattern tool. Okay, just clicking. It's good to use attenuation tool. Also, I will explain how this works. Let's choose the burden. The spacing can be 3 per 3.5 of spacing. Okay, now we have to place the left mark on this part of the blast, and this azimuth is very important for the last row. Okay, so it can be like this. Let's choose the number of holes per row. Okay, and let's choose the number of rows. Okay, 9 is okay, and let me choose also to have a staggered pattern. Okay, so now it's staggered. Okay, for me it's cool. I will just show that we can do also multiple burden and multiple spacing. And for me, it's important that on the first row, instead of 3 meters of burden, I have just 2 meters to try to adjust this better to the free face. Let's see if this goes well. On the moment I finish this, I'm happy with the result. Let's apply. We can still make a lot of changes. So the first thing that I will do here is to select these boreholes that are outside of the polygon. But even better, I will cut this blast like this, because sometimes it's better to instead of complying with this area, if we do this type of cutting of the blast of the shape, it's very helpful for the blast itself. Another thing is, let's check on the length of the boreholes, and because I forgot to go to bench bottom, okay, so the bench bottom is on 84. Let's see, we have here the Z. Let's see, it should be, we have some material, loose material here, but it's like 86, okay, in around 86, so I want 86 to be the bench bottom, and let's edit all the holes to the bench bottom, adjust bottom, okay, so going to change, everything is set up. I can now close my polygon. I don't need the polygon. I can take also the contour lines. I don't need those. Okay. Also, the bench bottom can be invisible. So let's work like this. Okay. Okay. So you can see after 23, I'm going to 25. After 161, I'm going to 166 because I deleted some holes. Let's go here and renumber all. Everything is set up. One important thing here is to define the azimuth and inclination of the first hole, because we can see that we have a free face very inclinated. So we have to adjust better our holes. So let's see how we can do this. So the first thing would be to set up the azimuth. So let's place the ruler, and for this direction be 277. Okay, so let's go to the first row and define the azimuth 177. Okay, with no inclination for now. So this is updated. I take this out. It's left control and right click on the mouse. I eliminate it. And now let's check on how this hole looks. Okay, let me put this bigger. Cool. One moment that I forgot. I have to set up also important thing is the stemming. It will implicate other things. So for all the holes, I want a stemming of 3 because I have a burden of 3. Let's start with that. Subdrill 1, it's okay. And I had the azimuth, I could put everything. And I will set up the diameter of production as 76 millimeters. Okay. done. So now let's go here, because now I have explosive charges here, so I can see the critical burden. That's very cool feature of this software O-Pitblast, is that it's calculating the critical distance. So I have an ideal burden of 3. I can choose these intervals of offsets that I can see. I can see the phase points. Okay. I will take these critical zones. We don't need that for now. So let's check this hole. Okay. So I will need clearly inclination here, because the free face is inclinated. So let's start by increasing inclination. Okay. Up to a moment that I have this better adjustment. If I increase it a lot, what will happen is that this will start to become very critical and low, and I can have fly rock. So I'll go all the way until that moment. Okay. Now I start to have here almost just 2 meters. I can take the other holes. I can leave this hole. Take all holes. Yes. So you see, it reaches a moment that it's dangerous to put a lot of inclination. So I will take this all the way through to this, because sometimes this is the best adjustment I can have in my free face. Okay, let's go to borehole number 2. I already know that around 20 is okay. Yeah, this is completely adjusted. 26. Let's see with 26. Okay, let me see if I can put more. Not bad. So I will do the same. So I'm in borehole number 4. Let's go and do this quickly. I'll go select all these holes. Edit hole. It will edit everything. Let me put 25. And let's go. So now the 5th. But you got the idea. We should see all the holes. Okay. And we should see all the holes, and if they are adjusted, cool. I will leave this like this. So, but now we have the second row that should have also. We can see burden on the toe. You can see now that we have like 3, and now we have 8. So what I will try to do quickly is to set up some different inclinations. I will make it smooth. Okay, up to make this more balanced. Okay, I will leave it. Now let's put like 20 degrees of inclination. Now let's put a little bit less. Like 13. Okay. And like 7. Okay. So we can see the burden on the toe is more balanced. Okay. So this is a cool thing that you might have a thought on this. So I'm happy with this. Another cool feature we have is to, on the results, see the burden distribution. Okay, so it will calculate the burden distribution on this ideal burden that we selected. So I selected 3 meters. So I should have a stemming around 3 meters. If it's less stemming than that, it becomes red. If it's very high stemming, bigger stemming, it becomes blue. So what I want is to you see I adjusted these holes, and these holes are this wall is more green. These holes I leave it like that, and they are blue. It means that in this area I might have some boulders and bad movement, and on these red points I might have critical burden less than 3 or almost 2. So I can have some adjustments. So I'll, for example, put this hole a little bit this side, and let's see what's happened. Let's calculate again the burden distribution. So what we want all the blast to be green. That's what we were aiming for. So in this tool is good to see the critical burden. We're just waiting for this. Okay, you could see this area is okay. This hole might take it out. I don't need those holes. Okay. Cool. So I have my design ready. Okay, I have my design ready, and but I want now a press split for this. So I'll show you quickly how to do a press split. So there are different options, but what would I do? I would create a line. I would simply create a line like this, and from here up to here. Okay, and now I would create an offset of this line. I would select both segments. I would put reverse, and I want a 2-meter distance. I'll apply. Okay, cool. I have my line, and now I simply go on boreholes, create pattern along a line, and I will select my half of the spacing. That's to 1.25, and I will select here. Okay, let me put just an offset. Okay, it's go like this. I will delete that. Oh, actually, it just created one hole. Yes. So now I have here my press split. Let me just correct this. Okay. Cool. And obviously I will renumber all the holes. And now I'll do a thing is line editor. So I have line 1, 2 up to, let's see, row number 7, 8. This is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I will edit the 10 row. The 10 row will be this. Okay, so now I can quickly edit the holes label, and the 10 row will be the press split row. Very easily, let me take the number and put the label. So A, B, C, all the way to the press split. Okay, cool. I'm happy with the results. So let's go to charge this all. Before that, I'm sorry. Let's just select the press split line. And I'm sorry, select the press split line, and identify this row as this holes as contour. Okay, so now I can do a different thing. I would basically edit parameters for the contour. So I want less diameter, okay, and I want, for example, bigger stemming, and I don't want subtrill, for example. So I'm happy with the, now I'm happy with the design. So let's go for charging. So let's use the same charge rule. This is commit a charge. I can show you the charge rule. Actually, I just have a booster and bulky motion commit from 4 seats, and I will apply for the contour. Okay. And now I will apply also the same for production. You can do this type of analysis. You can choose different charge rules for different type of boreholes. So let me see. I have these charges. Okay. And now let's go to the tie up. Okay, let's choose electronic. And I will do here, for example, I will use this tool vector, and I will choose a different angle. I'll choose, instead of, because this will make a vector. Okay, like this, I will choose a different angle, like for example, this angle. And I have to choose the burden relief. I'll keep this in 3. I like to see this like this. So let's go. I have just to select timing. Okay. Let me see the simulation. Okay. You can see right away that I have a problem here. Is that I don't want the press split to go on the same time. I want this press split to go before. So I can easily use the drag and connect or drag flow tool, and I will set the time 0 for this holes. Okay. Drag connect. I was playing with the scroll on the tab, and if you do that, it will scroll all the way and navigate through the tabs. Oh, I'm sorry, this changes to 10. Let me put 0. You can see I'm with different colors. If you want to have different starting times, you can do like this. Okay. So in the moment you join everything, it will become just one color. Okay. So I'm happy. Every borehole of the press split has the time 0. So let's see a simulation right now. So they all blast, and this carries on. Okay. So I forgot to tell. This is, I have to choose here my detonator. I choose Davitronic. But because we are talking, and as I told you, we have here on the database all the things that you have to put detonators. Okay, you have to insert here and put the price. So because I'm talking about tie up, and this is so important to vibration prediction, I will quickly show how can we do vibration prediction in our software. So we have to import seismographic data, our records, and then we can choose if we want to import all the channels. Okay, but we can work only with the vector sum, the distance, and the charge. Okay, when it's set up, we import, and it will generate an attenuation law. We can choose to see this on a logarithmic scale. We can, for example, see the low values of PPV. These are some outliers, and we can choose to eliminate the outliers, okay, or if we want reset the values. We can increase also our confidence level, okay, and I will save this attenuation law. Okay, it was insert, and now I can see how this will affect the structures on a map. This terrain that I'm working is on UTM zone 55, hemisphere south, so it's here on this mine, and it is already integrated with Google Maps. And what I have to do now is I have to set up my structures that I want to preserve. So for example here, let me see, petrol station, and I choose the PPV limit. It can be 15, okay. Then let me put here a structure. It can be a power plant. And I can put a lower PPV. Okay, that's the idea. We put the structures that we want to preserve. I'll say this is house, and it can go all the way to 16, for example. Okay, and when I have my structures, I just have to check the PPV limits. I have to insert my attenuation law, and it will calculate. Okay, so you can see in 100 meters I have 262 millimeters per second. On 600 meters I have 28, and we quickly go to blast results and click on structures. At this moment I don't have a problem with the structures. Okay, it was lucky. It was lucky. Okay. Okay, I missed. I have to edit here. It was 26. I wanted to put 16, but if I put 12, more strict measure, I will for sure have problems with the structures. Okay, so I have problems with the structures. One thing that we could do, because we have a lot of the charge blasting at the same time, is that we can fix this automatically using the fix function on histogram. But for that, I want to remain with my press split in at the same time. So I will do quickly a polygon. Okay, I'll do here a polygon. So I will select to fix just inside this polygon. I'll call this polygon production. Okay, and now I just have to click on histogram. I'll choose the window of time that I want to fix these holes, and I will select production and normal. Okay, so we can see we just have one hole blasting at the same time per time in the production, but press split they keep the same. Okay, so let's do another simulation, and it's cool. Obviously this has delayed my blast, but cool. So let's see. I still have problems with the structures because my press split is very a lot of holes, so a lot of charge also. So I could quickly make some changes on the drag connection. I will split this by trench, so I'll have like here. Then I'll put some delays so to divide this. Okay. So they are now in different time frames. So okay, close. So let's see. Now the histogram is a little bit different and slower. Okay. So let's see blast results. Cool. So I don't have problems with the structure now. Um, so so let's finish the tie-up. Now I want to export this for the field for my Davidtronic system. Let's go. Okay, but the software is telling me the connections are apparently fine, but I have to verify the path. Obviously, I'm sorry, but I forgot to make the path. So the path is just the order of connection, of order of the programming on the field. I can, for example, this is a pretty big blast. I will say for one logger, it will do this path. Okay, so it will connect all the press split holes. Okay, and the other logger will do they can start side by side, and they will do this. Okay, just have to tell the software what will be my what will be my route of programming this. Okay. I will just show you I'm misdoing this, and if I forgot something, the software will tell me. Okay. So I have everything set up. So I could export directly here for the system. I would have to associate the path A or B to some logger. Okay. So in terms of tie-up, this is cool. I have a good blast. I'm happy with the results. And now let's go to some other blast results. And I want to introduce you the tool of fragmentation prediction. Okay, so for this tool we have to go all the way to database and go to rocks. Okay, so here I have already two types of rock, and they have the same rock factor because this was not optimized. But in fact, if I want to create a new type of rock, I can do it like here, and I will choose granite of pit 3 because it might be different. But this rock factor is the most important for our model, QSRAM modified model, and we have to understand how this is built. So you can enter the properties here, and it will generate a rock factor. But even if you don't know your rock factor, we will find this through measuring the fragmentation. Okay, so we are studying this granite, and we'll go to the prediction. So this will work like this. I will have this blast, and after this blast, I will check my fragmentation, and in softwares like WebFrag, our partners that are providing a trial license to everybody present in this webinar, we could calibrate our rock factor here. So what we'll do, we'll need the real data of this blast. So I will open here a sample file, okay, and this fragmentation analysis, okay. So I have here my study, okay, the fragmentation analysis from orthophotograph, and I will put this on my second screen, and I will calibrate this on O-Pitblast, okay. So I have to put my X20 or D20 or P20, it depends on type of thing that you want to use. So in this D20 is 323 x50 5998 x80 and x90. Okay, all set. And you can see I will try to explain how this works. We have our geometrical parameters here with this rock factor, but now I'm putting an input. It's the result. So the software will calibrate the rock factor because it will know for these parameters with this rock factor I should have this value. But in fact I didn't got the result I was expecting. So my rock factor wasn't 10. In fact it is 13.61. So we accept this and we update our rock factor. Okay. So for now we have this calibrated for this blast. This is an iterative procedure, so we should have more measurements on the same areas and to have the better adjustment. But after 2-3 blasts, we could have a nice accuracy on this value. And because of this, after this we can use optimization module, and this optimization it's also easy to understand. We can get the values from our design. These are our parameters. Okay, we have now the rock factor calibrated. Okay, we can choose the limit of fragmentation that's most suitable for our machine, our equipment of excavation. And for example, I have some big excavators, and I can go all the way to 700 millimeters. Okay, and these are the constraints. These are the variables, and these are some constraints. And for example, I like to use the relationship between relation between spacing and burden as a 1.15. So I can go all the way here and change this. But because I made a nice solid and good blast, I don't have a lot of restraints here, just the oversize. So I will find optimized values, and let's see, the yellow fields are going to change. So let's go find the optimized values, and you can see the price might change because let's see. Okay, so it's proposing for me with these constraints to change the burden and the spacing to actually have less burden and less spacing. It means more holes, so it's calculating automatically the cost of my blast. Okay, so this is the optimization. We are not proposing to jump right to these parameters. We should do this fragmentation calibration every time that we do a blast, and we should optimize our type of blast like this. Okay. So I just missed to talk about the report. It's something that it's good. In every operation, our clients want to report about everything. So let's go here to print, and now we have the option of print and save to Excel also. So, but basically we have to select what fields we want to build on the report. Okay, we can change some options and configurations. For example, the drilling plan, I have like this. I have here the azimuth. I have angle. I can configure here the size. Okay, the size of the things. Okay, I can personalize this, and I can also, let's see here, change other disposition. Okay, so but basically we have here, I have selected everything. We can select the size. We can put our company's logo also here in this side. But let's try and see our PDF that was generated, and it's here. Let's see. We have a resume of the blast. So we have here the explosive ordering, accessories ordering, detonating cord if I add, blast resume, some comments if I want to put, charge rule, list of boreholes. Let me see more what I have. I have the drilling plan for the drill operators, detonators profile, um, detonator times, and I have here tie-up plan, isoline arrows, charge plan. I have here, this is very interesting, I have here my critical burden profiles, and obviously this is theoretical. If I import here O-Pitdev information or from other competitors like BoreTrack, you could see the real position of the hole, and you can study the critical burden of the real hole. Okay, so this one, I made it with carefully, but let's see some others that I didn't did it so good. Obviously, this should be adjusted. Okay, but that's the idea. Okay, so this is between the spacing of the holes. Okay, we got the explosive ordering and cost breakdown. So per hole, my cost per hole, per cubic meter, per ton, and that's it. Also, we got the histogram per holes, okay, and histogram per charge, and finally, with my prediction of fragmentation. This is basically what I have to show you guys. I hope that you like this course. And now we can go to answer some questions. Me and my team, also the team of O-Pitblast, started to answer some questions on the chat of YouTube. But I have here the question of Gabriel Filinkowski. So why did he put a deck between those layers, and what do the floor and roof wireframes mean? So those layers mean different geologies. For example, coal layers, and in some blasts, it's interesting to don't put explosives on those structures. The floor wireframe was actually the pit shell, so the last shape of the mine after excavation. Okay. Also, Tristan asked us, O-Pit is limited and how many points can import from a 3D point cloud. So O-Pitblast software can work smoothly up around 350,000 points, 350,000 million points. But O-Pitblast 2, the next version of software we will release, will be early next year, and it will be able to handle cloud points with a million of points. Okay. Other questions are being answered in the chat, and also you can email to us your questions to info@opitblast.com. Okay. So now I have to present that where our partners are providing free trial license for Android of WeebFrag, the measure of fragmentation software. And we are in this moment providing in the chat of the YouTube webinar, okay? And it takes me now the time to do the raffle of the second ticket of interconnected mining experience, because we done the first session of webinar in the morning. So these are the list of email that are signed. So I will draw. And congratulations to Jnunio. So you are the winner of the ticket. So congratulations. And now we are giving the second O-Pitblast backpack kit. So let's see who is the winner. And Nicolene Drabo is the winner of this kit of O-Pitblast. So congratulations for the winners of these gifts. So I will be able to answer all the questions that you might have. We invite you to answer those on the link on the info@opitblast.com. And it was a pleasure to provide this webinar to everybody. Stay connected to our social media. We are providing more webinar and more content in the web. So thank you very much. It was a pleasure, and stay safe.
O-Pitblast is looking for finders. Do you have contacts in the blasting industry? Wherever you are, if you have a business opportunity, talk to our consultants. Sign up and order our media kit. For more info about O-Pitblast, check out our social networks. Send an email to info@opitblast.com. Contact us and you'll be entitled to a commission. We can grow together, so let's do business all around the world. O-Pitblast. With us, it's possible.